Hello. So yeah, data scientist. There's a number of reasons why I feel uncomfortable with that title, and one of them is that it's very focused on how to look at specific problems with specific methods, and I'm more used to just winging it. So my name is Mikael Kullberg. I do threat research at Akamai. Akamai acquired a company called Nominum, so I used to do threat research at Nominum, where we look at DNS data and try to figure out what the bad guys are up to. So let's see if I can get this. Well, that's me. I like the title Jack of all trades better, much better. Yes, I've been working with the TCP IP stack for a while. Got stuck on DNS, and DNS is cool. And it's also an open data set. And there's lots of bad guys there. So there's plenty of cool stuff to look for. And here's what I was thinking of talking about. So I'm going to be rushing through these to sort of get an overview of all of them. And then I'm going to try to focus on the DNS privacy bit because, well, it's kind of important. So what we do is DNS filtering. I know that's not very popular in Sweden. It's mostly just a hassle. You have to do it. Some government-issued mandate that forces you to do it. But we do it for, well, security purposes mainly. The original, or the first implementation was basically to clean up our ISP's networks. We were seeing lots of amplification attacks. At some point, we saw the PRST attacks. Some of you probably still remember them. Some call them Chinese water torture. And all these were all pretty bad for ISPs in general. So we did successfully remove them, at least from the resolver end of things. And we also realized that, okay, so the things that actually launch these attacks within ISPs are typically bots. So the second step was kind of taking care of botnet traffic by shutting down the C2 traffic. And if the bots can't talk to the master, there's usually no attack, which is kind of good. So the second step in this was, well, apparently ISPs have subscribers. And those subscribers, they click on links and they do all sorts of things on the internet, and they kind of want to do that without getting owned or having their bank details stolen, etc. So the next step was malware and phishing. And well, bots are malware, but the focus here is sort of on the subscriber perspective and pre-infection. On the perspective of what you do with it, malware and phishing are pretty much the same. You're just basically looking at the DNS name and see if, well, is this malware? Then we'll just say it's malware and block it. If it is this phishing? Yeah, it's phishing, so we block it. Both the botnet and the malware stuff is also applicable to enterprise. And there are a few other things there, like exfiltration, DNS tunneling, etc. But these are the two main branches in terms of DNS filtering that's been done for ISPs. Now, so how do we do that? Well, oh, sorry, this one. So one of the things that we've realized is that we need to be really quick because attacks are getting shorter. They give returns early. So if you're slow, you missed it. And they're turning out to be regional. So whenever you're seeing attacks, you're going to be seeing them in a country or even inside just one ISP or one mobile carrier is typically the more usual case. So this chart just shows an attack, and this one's a couple of years old, where we saw the attack start, we followed it, and then we saw when the first security vendor gave us the domain name, and then we followed it for another 4 days. and you're well over 50% success rate before the security vendor actually posted that on a list. And like I said, that's old data. We have new cool malware like Flubot is probably not unknown. It propagates through Android phones by text messages. And those DNS names, they exist for longer, but they only point to the malware download site for about 10 minutes or a little more, 10 to 20 minutes. So if your detection is slow, or your mitigation is slow, or anything is slow, you're going to miss it. So well, here's an example of how we cluster malware. These are also kind of old malware, but basically you find features and you try to figure out which ones are in which category. This ties into the classification problem. You can be fast, you can be precise, or you can have classification. You typically can't have more than just one, actually, because I'm going to promise you that there are false positives in these groups. And if we're going to spend lots of time figuring out which ones are the false positives before we shift it out into the internet and block stuff, we're going to be late. So you got to pick. How do we do this? Well, we have a platform that we sell to ISVs. That platform has a bunch of DNS resolvers. All those DNS resolvers just dump their logs into Kafka. There is some correlation done on site, etc., for a lot of different purposes. There's lots of other machines as well. But the main point is that the DNS logs from the northbound resolution and from the southbound communication with the client are both being sent to this Kafka instance. And then for customers who decide to share data with us, and this is really a fully voluntary contractual agreement that is not connected to the actual purchase of our software at all. So we basically just say that it would be really nice if we got your data. And the benefits to you is that, well, if we have your data, we can see threats that are within your network. We can respond to types of threats that we really can't see if we're not seeing the traffic that's happening in your network. And a lot of ISPs think that's a good enough reason to give us data. And to pull all that home, well, we started this before Kafka had any idea that there were reasons to protect information. So we started out when Kafka was basically clear text to whatever Kafka thing that was close to you. And we needed to send stuff over the internet. So we had this entire infrastructure for doing what Kafka does naturally now, which is basically aggregate data. So we aggregate everything into our data center, and we pour it back into Kafka. And in Kafka, we do streaming or real-time analytics, and then we pour it out into Hadoop. And there we do sort of batch or static analysis on long-term data. So this is the sort of the basic data pipeline coming from, well, subscribers out here and into our processes on the other end. And the processes, well, these are all the usual suspects. Like you do correlation between different things and see if you can figure something out. You do ranking to see if this one is more popular than this one. Anomaly detection, we didn't see this before. Why is this here? Clustering, take some sort of feature, join them together, figure out what they have in common. We say these have this in common. Are they good? Are they bad? And reputation is sort of, well, everyone does that. That's passive DNS sort of strategy. And we have lines almost everywhere. We're just missing one. Then we'll have the pentagram where we can summon a greater DNS daemon than the one we have. So we're working on that one to make sure that we can get better at this. Anyway, that's what we do. Oh, we get lists too. The ground truth is not the something we have a lot of. We do know some domains to be really, really bad, and we know they're absolutely bad. So that's our ground truth. That's kind of like 1%, maybe, possibly. The rest is, well, it's probably malicious. So anything you dig out of malware is typically safe to say that it's bad. But in our world, we're just seeing DNS names pass by. On occasion, we can actually look at the HTTP connection, but we just look at DNS. It's just solution names, responses. Could be bad, possibly. Anyway, that was all I was going to say about filtering and what we do in terms of processing and figuring out what to block and what not to block. And now I want to go on to what I think is one of the more vital things about this. It's a lovely color, isn't it? It's actually one of the standard colors in our template, and I thought I had to use it for something. And since this is important, it needs to be sort of emphasized. And this is, well, it's one of the colors in the template. Anyway, because DNS data is somewhat, well, tells people where you're going. And some people don't want anyone to know where they're going, or at least not have easy access to it. So what do we do to make sure that this data is at least difficult to track back to the actual client? Well, the first one is synonymization. You basically take the raw data, you take the IP address and IPv6 or IPv4 address, and you run them through a AES encryption with a key to give you another IP address or another IPv6 address. I mean, you do the same thing for NetFlow. It's basically the same thing. This is the baseline. The majority, I think this is fine. Some carriers go further. You can have faster key rotation. I encourage this. I prefer to, if possible, 12 hours is a good cycle because it fits with other. Well, you can do more. Like joining multiple IP addresses into one lump makes my detection a little bit more difficult, but it's also okay. And then whenever we take this data, so the raw data is the one that we're sort of careful with, because this one has it has the identifier, which you potentially could break. It has sequence, and it has timing, and all those things in one big nice list, so you can just go and try to figure out who it is, right? So the raw data is the one that we see as well, we don't hand it out to just anyone. Intermediary data, and we have lots of that. All the data that we actually work on is intermediary data that sort of comes from the raw data. So there's a number of processing steps that sort of refine this into whatever features we're interested in. If any of those sort of subsequent features retains the key identifier, the idea is that you run CryptoCAN again just to disconnect it from the original data source. So you can't just go and say, oh, this one was interesting, let's go back and see what actually happened. You need to ask someone who they trust. And I don't know who they are, but whoever they trust will allow you to go back and look at the original data. So all that's very good about the identifier itself. The problem is that if you're still keeping the data for long periods of time, you have a very long history of what people are doing. So we have sort of tried to get down to as small a data set as possible. And this is easy to sell to management, because we're saying that, well, we really don't need this huge Hadoop cluster. We need one that fits a much smaller data set. So we don't need to have this many machines. It's enough with this many machines, and then we only retain the data for 7 days. I think the goal now is 3 days, because we're fighting malware that's happening now. If it happened a week ago, well, that could be interesting, but typically there's limit. The information, the freshness of the information dies off really quickly. So we have no real reason for going back to 7-day-old data. The only case I can remember was when the Amazon attack happened. I did have to go back and look at old data because, well, then we had an interesting event related to DNS that we really wanted to figure out, and I guess someone wanted to put it in a PowerPoint slide or something. And when it comes to the intermediary data, well, we keep that longer. There are sort of stages. So if you have a risk of information leak that would identify a user, those are kept shorter. If we're looking at statistics like, okay, so in this ISP, how many lookups were made for Google? Well, those we keep for 13 months. And good luck with figuring out what those 6 million odd clients were. Aggregation. Well, that's the important part. That's where we do all these intermediary data sets. So when you do your aggregation, you figure out which features do I actually need, what features are useful to detecting malicious activities, and that does change over time. But you're really just interested in those features. So client identifier is a grouping key. You use it to sort of keep the things that were potentially malicious within one sort of search space. And you're just being careful with that. So the intermediary data has some of these things. But when it comes to client identifiers, even before GDPR, or before it was a big thing, client identifiers had instabilities. And the biggest reason for that was DHCP. We had a lot of customers early on, we had a lot of customers in South America, and it seems they don't quite have the address space to cover their entire customer base because they're recycling their IP addresses like crazy. So the base assumption is that we have a 24-hour window in which the client identifier is stable. Potentially 12 hours is a better limit. And we're really not collecting data on clients for long term, because I have a client, I have information about that client. Yeah, I hear that. Huh. Let's see. Okay, is that better? Yeah. Am I on mute? Anyway, the baselines on clients is useless because sure, I can keep the same identifier for a month, but that could be, well, if I'm lucky, it's one client. If I'm unlucky, it's 30 clients, different ones. And if I add that together, it's gibberish. So we track clients very little. Now, is that enough? Well, it's obviously enough for our customers, and according to lawyers, we're doing great on GDPR compliance. However, is it good enough for you guys? So that depends a little bit on your threat model, and this is the part where it gets interesting because, well, I'll get to that. So the Mosaic Effect. Basically, anything that you find in a DNS record to be reflected in an HTTP log or some log somewhere else, right? It's kind of useless to use DNS. Well, some people use DNS for other things. Then you don't have a secondary connection. But in most cases, you have a secondary connection that goes somewhere. And if you have a few of those, you typically can sort of correlate and by timing and figure out who this is based on the sequence of events. So that's the Mosaic Effect, and DNS is pretty much the poster child for it. Here we have 4 different entities that are sort of colluding, but what happens if you put a CDN in this? We're not correlating our CDN logs with DNS, but we could, in theory, and then you pretty much have the keys to the kingdom in terms of de-anonymizing information, and that's, well, you could question if it's a good idea to put the DNS and the CDN in the same entity, but apparently we do seem to be trustworthy enough to handle this. And we're not the only ones who are capable of this. In reality, you don't really need a CDN to be able to do this de-anonymization. Individualized queries is a cool new trick that lots of trackers and some large companies, I'm not going to mention any today, but you all know them, basically are keying the DNS queries with IP addresses or an identifier that looks awfully a lot like an IP address, or just a hex string that has enough space to keep quite a bit of information. I particularly like the security vendor one. I think they took iodine and just ran with it because, wow, took a bit to fit that one in. Summary here is, well, DNS filtering is actually still useful. It's a relevant security control, and companies should be doing it. They don't need to buy our stuff to do it, but they should be monitoring DNS because DNS is actually a very good canary for lots of stuff. So it's a relevant security control, and we're doing it on scale for ISPs, and it's not 100% effective. If any of our salespeople say that, please let me know. I want to have a chat with them. But it sort of dampens the whole landscape a little bit. Now, threat research, we're in a maximum utility sort of strategy, which means that everyone hates us. We're sort of walking the line between having false negatives. That means that your subscriber just got infected. False positives, that means that you just got a support call. So where do we stand? Yeah, it's tricky. And this is also the balance between sort of precision recall. So you're how effective you are versus how many things you broke. When it comes to maintaining this data, the grouping key is really irrelevant. It doesn't matter. You can call it whatever you want. It's the fact that you're grouping things that's relevant. So the fact that you have many queries that are coming from the same individual or entity or anything. And if you have them in sequence, that's better. If you have them timed, that's way better. So that's the whole idea that, well, we're anonymizing or pseudo-anonymizing IP addresses. Well, yeah, nice fig leaf. We have that one too. The Mosaic Effect, well, makes people like me really scary. I mean, a CDN, we have, I don't know how many of the DNS lookups on a given day that a user would do that would end up on our surface. Lots. But the trick is that anyone who actually has a resolver that does filtering or does modification of responses, they can just generate their own fingerprints. It's like, well, we're sending this one through a proxy just to make sure that we know what it is. So we send, and then we send this query through a proxy, and then we know what that one is, and then we can just correlate. And, well, weird-looking subdomains. You guys really should look at DNS traffic. You look a few lines down, it's like, why? Why? what are they doing? It's like, you can see everything. There's DNS tunnels, those are pretty obvious. But people are sending all sorts of information. I know security vendors were using this for what are they called? Virus identifying hashes. Hashes was the word. So you see all sorts of stuff that isn't really just looking up a name to find where you're going. That was it for my presentation. So are there any questions?
Thanks, Michael. We have some time. Question in the middle there. Just wait for the mic and yeah.
Hi, thanks very much. About that last point, what about noise? Back on your pentagram slide, do you take DNS noise and do analysis on it? You know,
oh, absolutely.
Things like chromoids, but the other stuff too.
Oh, so long tail research, that's the best, right? That's where all the tests for malicious activities are happening, and all the just we're sending something, and that's interesting. Yes. So yes, long tail, fabulous place to be.
Did I see another question? No? Nothing of a mentee. Well, thank you so much, Michael. Please join me in thanking Michael for his presentation. Thank you.